everyone. In this session, we will see about how can we implement a queue using a linked list. In the last video, we have seen about how can we implement a queue using an arrays. So in a queue, generally we have seen different operations like enqueue, dequeue, peek, and display. Where enqueue means insertion, where dequeue means deletion, where peek means it will show the first data available in the queue, and then a display means which will display all the data in the queue. So now here we will implement a queue using a linked list. So now for example, this is a node. So at first as a program, we should create a node first. So for that we will write a code over here. So and then as program goes by, we will create a link between all the nodes. So at first we should create a node. So for that, what we will do, we will use a structure. Why do we use structure? Because here we have different data types are there. So we will use a structure over here. So structure for a node int is going to be data. So this is going to be data, and then this is going to be the next pointer. That means that it will point to the next node address will be stored over here. So that's what we have created a structure for a node. So then at first we'll go for an enqueue operation. So in the enqueue operation, before going to enqueue operation, we have an two pointers in the queue. One is called front and other is called rear. So now there is no data available in the queue. So initially both front pointer and rear pointer will be equal to null. Both front pointer and rear pointer will be equal to null. That means that there is no data available in the queue. So now we will go for an enqueue operation. So for the enqueue operation, we will use an through variable called x. We will get the data from the user. We will get the data from the user. Then once we get the data from the user, then what do we do? We should allocate a memory size. We should allocate a memory space for the node, and then we will put it in the new node. So now what happens over here? Yeah, new node is a corresponding local pointer, new node. And then already we have seen how to allocate a memory space. If you don't know, then see the previous videos of linked list. So new node is equal to struct node and memory allocation size of struct node. So once new node is created, so this is a new node is created. Once new node is created, in the new node of data position, I will store the x. So for example, the x value is, there is something called, the first data is something called 9. So in the data position, we have stored a 9. The new node of data, we have stored a x. That is called 9 has been stored. In the new node of next, that means this is the first data. There is no second data over here. So I will declare here that as a null. So in the queue, we have only one data, that is a 9. There is no second data. So we have given new node of next as a null. So now once you give a data over here, we should add this data in the queue. So for that, we should declare the address of new node in the front and as well as the rear. So here we have two fields, front and rear. So now if front is equal to null and rear is equal to null, if front is equal to null. So since it is a first data, then what happens over here? Front is null and rear is null. So when the front is null and rear is null, then what do we do? We will declare the new node address to the both front and as well as the rear. We will assign the new node address to the both front as well as the rear. So here both front is equal to rear is equal to new node. So what happened over here? It will assign the new node address to the both front and as well as the rear. So what's the new node address? It might be, for example, it's a new node address something called 100. So we have stored a front is equal to 100 and rear is equal to 100. So this node addresses is 100. Okay, so first data. Okay, front is null, rear is null. So we have assigned the both for both variables, front and rear as a new node address. Then, for example, if I'm going to create a second data. So for a second data, what happens over here? Same procedure. I have given 5 and then null. So now second data has been created. So now I should link this into the queue. So then the second node address something called 200. So now I should link this node into the queue. So now at first what do I do? I should go and change this address to the 200. By that the link is created to the next node. So how can I go to this position? I can go to the position called rear of next. So rear is 100. 100 of next is this position. So rear of next is equal to new node address. So that's a 200. That is a 200. So now what happens over here? The link is created. The link is created. So once a link is created, but here both front is 100 and rear is 100. So I should update the value of rear. The rear is equal to new node address. So rear is equal to new node. The rear is equal to 200. Then if you're going to insert a third data, then for example, there is something called 7 and there is a null pointer. So now I should go and change the address over here. So rear of next, 200 of next is this place. In this place, I can give a new node address that which is something called 300. So I will change it to the 300. So then what happens over here? The link is created. The link is created. Once the link is created, I should update the value of rear. So the rear will be equal to the new node address that is called 300. So the same operation we should write it in the code. So we will have an else condition over here. So in the else, at first what do I do? I will go and change the rear of next as a new node value. Rear of next as a new node value. So here rear of next is 200 of next is going to be new node value, and then rear is equal to new node. Rear is equal to new node. So this is how we can perform enqueue operation. Okay, so now we'll go for display of data. So in the display of data, what happens over here? So as usual, if front is null and rear is null, then that means that there is no data available in the queue. So we will declare it as a empty. We will declare them as a empty. So if front is null and rear is null, then queue is empty. Else, what do we do it over here? We will have a local variable called temp. We have a local variable called temp. So now what do we do over here? I will assign the temp is equal to front. So temp is equal to front. So the temp is equal to front means what happens over here? Temp is equal to front means temp is equal to 100. Okay, so at first I will display the data. Temp is equal to front. So until which point I'll be keep on moving? Until it will be goes to null, I'll be keep on forwarding. So now what happens over here? At first I'll print the temp of data. So at first I'll print the temp of data. Temp of data is 200. So temp 100 of data is 9. 9 will be gets printed. Then I will update the value of temp. So now temp is 100. So I'll update to the 200. How do I do? Temp is equal to temp of next. Temp is equal to temp of next will be get updated. So then I'll check for whether it's null or some other value. It's not null. It's some other address. So once again repeat the same step. So until it becomes null, it will be keep on going for in the loop. So this is operation called an display of data in the queue. So now the next operation going to be dequeue. So in the dequeue, once again, if both front and rear are null, then it is simple. The queue is empty. The queue is empty. I am having a local variable called temp for some purpose. We will see it. So then at first I'll check for front is null and rear is null, and it is an underflow. It is an underflow. There is no data available in the queue. Else, okay. Else, what happens over here? We should delete the first data. So for that, the temp will be assigned to the friend. Okay. So and then the friend, for example, we'll see this example. So always in the queue, the deletion will happen at the front end and insertion will happen at the rear end. So now if you're going to delete this data, then what happens over here? This data should be gets deleted. So now front, I should change the front to 200. Okay, because then only the link will be gets broken. So how can I change the front value over here? Front is equal to front of next. So front is 100, 100 of next is 200. So I will assign the 100 of next is to the 200 to the front. So now what happens over here? The front becomes 200. The front becomes 200. Then I can free the memory space of this node. Then this will be get deleted. This will be gets deleted. Okay, so now for that logic, we will write the code. So at first we will assign the temp is equal to front. So temp is equal to front, and then temp of data. The 99 will be gets printed, and then front will be assigned to the new front value, and then free the memory space of that node. That node will be gets deleted. Okay. So this is the operation of an dequeue. This is the operation of an dequeue. Okay, and then for peak operation, it's simple. Just we can store, we can print the front of data. We can print the front of data. So front is null, rear is null. There is no data available in the queue. Else, the front element is front of data. What's the front over here? So in our case, the first data front is equal to 100. So 100 of data is going to be 9. So peak will always show the first data available in the queue. So it will print the front of data. So this is how you can implement a queue using a linked list. So in this session, we have seen how to perform an enqueue, dequeue, and display and peak operation using a linked list. Thank you.